Okay, 3.7 in the text. We're going to start talking about graphing rational functions. Rational functions are fractions where the numerator and denominator are both polynomials. Okay, so that's what we're going to work on. We're going to consider this first function, f of x equals 1 over x, and it's an easy one to graph. Let's just plug in some points and see what's going on. If I plug in, obviously I can't plug in 0, 0 is not in the domain. Plug in 0, get 1 over 0, which is undefined. But if I plug in 1, I get 1. If I plug in negative 1, I get negative 1. If I put in 2, I get 1/2. If I put in negative 2, I get negative 1/2. And if I put in, say, 3, I get, or so let's say, let's go to 10. Let's go to 10, I get 1/10. And negative 10, I get negative 1/10. So, excuse me, negative 1/10. So, those are easy to plug in. What happens if I put in like a fraction? What happens if I put in like 1/2? What happens? So if I put in 1/2, you get 1 divided by 1/2, which is 1 times 2 over 1, which is 2. And if I put in negative 1/2, I get negative 2, right? And if I put in positive 1/10, I get 10. And if I put in negative 1/10, I get negative 10. So if I kind of graph this out, plotting my points here, I'll go ahead and plot it in blue. I got 1, 1, right about there. Negative 1, negative 1, 2, 1/2. As we get lower here, we're getting lower as we go. Negative 2, negative 1/2, all right? If I have 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I got 1/10. If I have negative 10, I got negative 1/10. Okay, so it's going like this, but what happens is I get closer to this y-axis. If I put in 1/2, I get 2. And if I put in negative 1/2, I get negative 2. And if I put in 1/10, which is really close to this y-axis, I get 10. If I put in negative 1/10, I get negative 10. So the graph looks like this. Okay? Now, this is very important that we understand what's going on here. First off, what happens around where my denominator equals 0 is very important, okay? And the other piece that's important is the end behavior. What's happening if we zoom out real far? Okay, so we talk about these things and write them down in certain ways. First thing I want to say is, what happens as we approach, well actually we'll start with this side, what happens as this graph, you're on this little blue line, what happens to the height of this blue curve as x gets closer and closer to 0 from this side, coming from this direction? Well, as x gets close to 0 from the left, from the negative side, from the left, what happens to the heights of this function? Well, the heights of this function get larger and larger and larger negatively, so we say f of x goes to negative infinity. As x approaches 0 from the left, the heights, f of x equals 1 over x, okay, the outputs become closer and get closer and closer to a very large negative number, okay? And as x gets close to 0 from the right, okay, I'm on this blue curve. I'm cruising on this blue curve. I'm coming from the right-hand side. Positive is over here, right? Negative is over here. So from the right-hand side, what happens to my heights here? Well, again, I'm cruising on this blue function. I'm getting a little bit taller in terms of height, a little bit taller. All of a sudden, as I approach 0, I get taller and taller and taller. We say the heights, f of x, right, the outputs, go to positive infinity, okay? So as we approach 0 from the left and as we approach 0 from the right, okay, our outputs, one approaches negative infinity, the other approaches positive infinity, right? Our height goes to infinity, our height goes to negative infinity. So this is happening when our denominator equals 0, right? That's why we approach 0, okay? Because that was when our denominator equals 0. We'll look at a couple examples of this later also. But also what happens in our end behavior. What happens as to our heights as, so over here we were talking about, what happens to our heights as we approach a certain number? Well, let's talk about the end behavior. What happens as x goes to infinity? In other words, as I approach, if I'm cruising on this blue line, getting closer and closer and closer and closer and closer to this very large abstract number, what happens to the height of this thing? Well, it keeps getting smaller and smaller and smaller, and it approaches a height of 0, doesn't it? Okay? But also, as x goes to negative infinity as my x values approach larger and larger and larger this way, what happens to the height of this thing? Well, it used to be really large negative, right? Negative 10, negative 2, right? Negative 1, and then negative 1/10, negative 1/100th. Those heights also approach 0. Okay? So, this type of notation is something we're going to have to get really used to. We'll take a look at another example right now. All right, before we take a look at that example, actually, we're going to look at this definition. The line x equals a is a vertical asymptote of this function y equals f of x if f of x approaches positive or negative infinity as x goes to a from the left or as x goes to a from the right. The line y equals b is a horizontal asymptote of y equals f of x if f of x approaches b as x approaches positive or negative infinity. Okay, that seems like a lot. Sometimes an example kind of helps illustrate exactly what's going on. The first thing is I've got a rational function. It is a quotient of two polynomials, a polynomial divided by a polynomial. Okay. So the first thing we want to do is if you can factor the denominator, factor the denominator. In this case, it factors pretty easy. X minus 4, x minus 1. Okay. Now, if I looked at this graph, first off, we know the domain is all reals except for what two numbers? 1 and 4. Why? Because if I put in 1, I get 0 in the denominator. If I put in 4, I get 0 in the denominator. 0 in the denominator is bad. The only numbers that give me a problem, those numbers are not allowed in the domain. Okay? So, at 1 and at 4, 2, 3, 4, I've got problems. Okay? I cannot plug those in. So this graph will be graphed kind of nice, but it won't be graphed in those two locations. All right? Okay, so what happens as we approach those things? Well, if you remember in 1 over x, 1 over x has the case where if x equals 0, then my function doesn't exist, okay? Because you can't have 1 over 0. Here, I can't have 3 over 0. I can't have 3 over 0. So I want to look at what happens as I approach 1 from the left, 1 from the right, 4 from the left, and 4 from the right. And so we'll take a look at this, okay? So what happens? So right now, I'm going to check right now. We're approaching a distinct number on the x-axis, so we're looking for vertical asymptotes. What happens as x approaches, say, 4 from the left-hand side? All right. Actually, let's do 1 first. We'll do 1 first. A little bit easier for numerically. As x approaches 1. So we're approaching 1 from the left. Okay? I'm on the x-axis and I'm approaching. What happens to the heights? Well, you could always make, if you don't understand, you can always make an f of x chart and see what happens. All right, let's approach 1 from the left. So give me a number close to 1, approach from the left, maybe 0. Okay, 0 is okay to plug in. Okay, if I plug in 0, 3 divided by 0 squared minus 5 times 0 plus 4 equals 3/4. So 0, 3/4 is a point on the graph. Good. Right there. What happens if I get even closer? Suppose I put in a number like, say, let's go with 9/10, okay, or something like that. Or actually, let's go 0.9, okay? So if I plug in 0.9 here, what happens? Well, I'm going to get a negative number here. I'm going to get a negative number here. I'm going to get, this will be 0.1, right? And 0.9 minus 4 is negative 3.1. Is that right? So I'll get negative 3.1 times negative 0.1. Negative times negative is positive. What happens when I have 3 divided by, this will be 0.31, right? 3 divided by 0.31. Well, it turns out that's going to be a large number. Calculator. I don't know exactly what number it is. 3 divided by 0.31. I got 9.6, okay? And what happens if I put, say, 0.99 in there? Well, then I'll have, let's see, 3 divided by 99.667. And if I put, say, 0.999, what number are these getting closer and closer to? 1. We're approaching 1 from the left, from this side. So I plug in 0.999. I get 999. I think we're seeing a pattern here, huh? So, if I graph these points, 0.99, right? 0.99, really close, way up even higher. 0.99999, way up even higher. What's happening to these things? As I get closer to 1, I need a blue pen. As I get closer to 1, the graph of this thing is going to infinity. As x approaches 1 from the left, the graph of f of x approaches infinity. It goes higher and higher, gets taller and taller. And we do the same thing as x approaches 1 from the right. Make your x, f of x chart. Okay? And so give me numbers just to the right of 1 that get closer and closer. Maybe we go 1.5, then 1.1, then 1.01, then 1.001, and see what happens, okay? So if I put in, say, 1.5, okay? Oops, did I make a mistake there? Let me double check. 3 divided by 1.5. Yeah, I have a negative number. I get negative 2.4. And if I plug in 1.1, oops, got an error, typed something wrong. I get negative 10.34. Okay, and if I keep going, 0.1. Negative 100 approximately. This is going to be negative 1,000 approximately. And what happens here? As I approach 1 from the right, I have negative 2.4, I have negative 10, and so forth. These numbers, again, these are just points, right? These numbers get closer and closer to negative infinity, right? Getting larger and larger numbers. And what that says is that we have this imaginary line that we're going to approach and get closer and get closer and get closer to. Okay? That's exactly what that says. Now what happens now? So as x approaches 1 from the left, fx goes infinity. As x approaches 1 from the right, f of x approaches negative infinity. Okay? So that's when we approached 1 from the left and right. Okay? Now we can approach 4 from the left and right. So let's go through this, and let's do it with 4. Okay. So now we're going to approach 4 from the left and 4 from the right. What happens to my function? Well, again, we're approaching 4 now. So what happens here? So we'll put numbers really close to 4, but not quite 4. So if we put in, say, a sequence of numbers like 3.5, 3.9, 3.99, 3.999, and I put in numbers like, over here, 4.5, 4.0, excuse me, 4.1, 4.01, 4.001, that type of thing. We'll see what the outputs are. Give me 1 second, I'll plug them through.